Okay, so this is the Sartorius Instant Segmentation presentation. We are going to be covering the Sartorius Instant Segmentation, a competition that was presented by Kaggle online. This is for our Artificial Intelligence course over at SUNY Brockport. My name is Christopher Steves, and I am here with
Jonah Schnettler.
And Ryan Gibbs. Not joining us today is Brandon Lisowski.
So the competition itself was our prime motivator was just trying to find one of those AI projects to work on. And Kaggle, for those of you who don't know, have lots of really interesting coding projects that you could go and look into. This one in particular was partnered with Kaggle to do Sartorius. Crap. Tripping over my words. Kaggle partnered with Sartorius. Sartorius is in the process of trying to create a instance segmentation of cells, specifically from the look of things, brain cells, those being neurons, astrocytes, and neuroglioblastomas. They have presented a data set and also a bunch of live cells images that and a CSV file. Those are just all the data that they presented. We saw some people in the competition, I think, bringing outside data, which probably would have been helpful
Beneficial
for us. Yeah. But we didn't really know where to grab those resources. But yeah, so that being said, we had a plan, and we did end up actually getting the model working, which is what one of our biggest problems was. But did you want to go over the plan, Ryan? Or
Yeah, I'll do that. So our plan from the beginning was to use the following tools to try to have multiple cell instant segmentation models running and to compare them to see which was best or which performed better. We wanted to use Detectron, the original Detectron. Also wanted to use CNN, which is a convolution neural network, which utilizes the Keras API. And the strongest and most likely to be successful of the three initial ideas was Mascar CNN, which is a descendant of CNN, which uses TensorFlow and Keras, and it allows you to make a pixel mask of the segmented image. And I say that was the plan because sometimes plans change. Each of the tools we used had a long list of dependencies, and they were numerous and unending conflicts trying to get all three of those installed and running correctly. So many version mismatches and a lot of error tracing, which resulted in a flurry of difficult to track down problems and difficult to find solutions. So we had to change the plan up a little bit. So instead, Jonah got Detectron 2 working on his device, which was a groundbreaking achievement considering what we had done up to that point. Detectron 2 is a ground-up rewrite of Detectron. It's PyTorch based and highly modular, and it actually utilizes fast RCNN and Mascar CNN. So it utilizes one of the models we couldn't get working earlier, or one of the tools we couldn't get working earlier. And ultimately, we had to move the goalpost, kind of make the shot a little bit easier to take. So our goal was just to get this model trained and to get some segmentation done, to get some results. And then once we got that done, our goal was to improve upon those results. And that was the new plan. That was the goal we set out with once we finally got something working. And a quick overview of Detectron 2. It uses ResNet as its backbone, and it creates anchors, which then get turned into regions of interest. Fast RCNN takes those regions of interest and boxes them in as long as there's a high enough probability of something worthwhile or something that we're searching for being within that region. That gets passed off to mask CNN, which creates pixel object masks that are differentiated between the different classes that they can find. And that is the result that you'll see eventually. Do we want to move on to someone else talking about the next parts? We're just talking about the slides or the images.
Right. We're going to move on to the actual image segmentation portion, and we'll throw up a bunch of images and stuff like that from the presentation Ryan put together. But next on, we're going to move on to the debugging process and the struggle that came with actually getting Detectatron 2 working. And the one who actually got it working was Jonah. So Jonah.
Hello.
Hooray.
Yeah.
So we're going to start the run of the Detectatron model that we have a small segment prepared. And then Jonah can kind of walk us through some of the challenges that he had with it and just getting the model functioning in the first place, as well as some things that he had to do in order to change it up enough in order to get it running on Windows, that sort of thing. So starting the video now. Go ahead, Jonah.
I do not have that video up.
It's okay. I've got it running. So you just...
I'm just gonna assume we're looking at the training process right now.
Yes.
I don't believe we did the. So we also had to convert the data file into a JSON file originally. That way we can use it to work with Cocoa tools that are already involved within Detectron. It kind of gives it a little bit better processing time. It kind of cuts down on the whole full total runtime of the entire model. So that was the first thing I had to try to get working, which got us to the point where we can actually start running a training procedure for our model to build the actual model to test at a later state. But if you're looking at the demo, I'm assuming we're seeing some output right now. We got the iterations being displayed that shows an ETA, which is an estimated time for the actual runtime of this training procedure. We can see our total loss as that progressively goes down by the further iterations we go through. We can also see more specifications on what's being lost at which point. We also will jump through a little bit just so you're not watching this, 20-minute process. The demo here is being supplied by Brandon. He ran through this. I helped him set this up so he can actually run it as well. Where are we at in the demo you have right now?
Right now it is just finishing inferencing, and now it is
Inferencing of what out of 121?
119 out of 121.
Okay, so I'm just ahead of that. So the inferencing is just, I think, switching to the validation so we can validate the data that we've predicted. And then in a later state, you'll be able to see the actual validation information images versus the actual predictions. And you can see that it actually is picking up on stuff from the validation and still being able to catch it. It does miss some things because we still have some loss. But we do make more progress with our actual predictions.
Right. And we've got images up now.
You got images up now?
Yeah.
Okay. We could pause it right there and you can kind of see how the difference is. The images on the left are the validation versus the images on the right, which is what we're predicting. For this run through, we are getting a lot more instances being segmented. In the middle right column, you can see the huge change from the left to the right. We are catching a lot more images there. That's kind of hard to see because of the grayscale background and general. Don't know how to describe.
Cluster of color.
Yeah, it's really hard to see. But looking at the video as is, you can see there's a lot more color on the right versus the left. We can see that if you were able to see the left image a little more clear, there is a lot more going on there, and that we're actually catching a lot of that. But if you were to go to the image below, we do lose some still. It's hard to see in that middle image because there's so much going on. But the bottom and the top images there, basically, we have 3 images that are being randomly pulled from the data set, and we're being able to see the validation versus our actual predictions. So the targets left, predictions right. You can kind of match up where everything is. The colors aren't specific at this point in time. It's just to show that we're having segmentation appearing.
Right. And then we
Uh,
go a little bit ahead to one of these more enlarged images.
yeah. So this is specifically pulled out from the data set so we can actually see a little more clear what is happening within the actual image. We have mostly, what is that cell type?
Astrocytes.
Astrocytes. Yeah, so these are just all entirely astrocytes in this image. We can see that we're actually pulling most of this data. It's kind of getting some correction towards the actual specific dimensions of each of these. But for the most part, it is relatively accurate. We have achieved mostly 80% accuracy from the model and code that we've been working with, which is kind of hard to improve upon, but we have a pretty solid working state as is.
Right. And we were able to. The cool thing about this is that it's with the Detectratron too. Like getting the CNN to work, that only worked with classifications, but this one actually does classification and the segmentation and the targeting.
Boxing.
Yeah, boxing.
Yeah.
So yeah, it's kind of like a nice all-in-one package there.
So if we move on in the demo, you can actually see the instant segmentation where we're getting the mask versus the original image. They're slowly being ran through and pulled up, so you can see I think we had a total of 7 test cases in this scenario, just to see all of, like, the good run-throughs of testing against specific models. These are the images that had the best. They were the easiest to work with. We have other images that we've tested against that it doesn't quite get a nice clear mask of, but that was kind of explained to be a harder data set or a specific set of images to work with. I don't know where we are in your video. Mine just ended.
I'm just showing a little bit more of the segmentation, and yeah, done. But those were our results. Improving results. At least our attempts to improve the model and achieve higher results were unsuccessful. That's because this is really hard stuff, and Dr. Yu, our professor, warned us about that, and we kind of did not heed his warning.
We were very ambitious about this project going into it.
Right.
Working with it, we figured 3 cell types or neurons we can actually identify. Just get familiar with it. We can at least figure it out from there.
Yeah.
Proved to be a little more difficult in the long run.
Yeah. Our attempts at getting better results ended up just resulting in poor detection and looser masks, and still unsure how bad, as some cell types were meant to be ignored, but as the Sartorius prompt warns, they're notoriously hard to identify. So I don't know, can't feel too bad about it, but I don't know. We'll try to throw up one of those images of how of what our project should have looked like had we had many years of artificial segmentation experience and all that kind of stuff. So in retrospect, for our first independent foray into neural networks, cell instant segmentation, that was a bit of more biting off more than we could chew, and we should have stuck with our Titanic survival project, because that would have been way easier.
I think we would have figured out who would have survived the Titanic in a much better time frame.
Oh yeah, for sure.
Yeah.
But lessons learned going forward. Who knows? With a bit more experience, I know I'd still be interested in further looking into stuff like this, just as a maybe not professionally, but more of like an interest in like a hobby or something. little side project to add to a personal GitHub, you know?
Perhaps we weren't experienced enough to throw our weight into cutting-edge medical research.
Yeah. But that about wraps up our presentation at the moment.